State and prove the Sturm's separation theorem. Statement: if f of x and g of x are two linearly independent solutions of a differential equations d over dx px dy upon dx plus qxy equals to 0 on the interval a is less than equal to of x is less than equal to of b, then between any two consecutive zeros of f there is precisely one zero of g. Proof: let x1 x2 between the two consecutive zero of f of x on closed interval ab, that is f of x1 equals to 0 and f of x2 equals to 0. Since f of x and g of x are the linearly independent solutions, therefore g of x1 not equal to 0 and g of x2 not equal to 0. Let us now suppose that g of x has no 0 in the open interval x1 less than x2. Since f of x and g of x are continuous functions, therefore f of x upon g of x is also a continuous on x1 is less than equal to of x is less than equal to of x2 and has continuous derivative. Further, f of x upon g of x is a 0 at the end points of the interval x1 is less than equal to of x is less than equal to of x2, because f of x1 is 0 and f of x2 is 0. Therefore, it satisfies the condition of the Rolle's theorem on x1 is less than equal to of x is less than equal to of x2. Thus, d over dx of f of x upon g of x is 0 at x belongs to eta, where x1 is less than eta is less than x2, which implies g of x into f dash x minus f of x into g dash x upon g of x square equals to 0 at x equal to eta. Therefore, w of f of x and g of x upon g of x square equals to 0. W of f of x g of x is equal to 0, but we are given that f of x and g of x are two linearly independent solutions of therefore w of f of x and g of x not equal to 0 for all values of x belongs to closed interval ab. Thus it leads to the contradiction. Hence our assumption that g of x has no 0 between x1 and x2 is wrong. Thus g of x must have a 0 between x1 and x2, the two consecutive zeros of f of x. Let us now suppose that g of x has more than 1 0 on x1 and x2, and let x3 and x4 be the two such a consecutive zeros of g. Interchanging the f of x and g of x, then by the preceding discussion, f of x must have at least 1 0 x5 in the interval x3 and x4 open interval, but f of x has two consecutive zeros x1 and x2 which are to be outside the interval of x3 and open interval x3 and x4, that is f of x has no 0 between x3 and x4. Hence the assumption that g of x has more than 1 0 between the two consecutive zeros of f of x is not correct. Thus g of x must have only 1 0 between the two consecutive zeros of f of x. Hence the zeros of the two real linearly independent solutions of equation d over dx of p of x dy upon dx plus q of xy equals to 0 separate the 0 of the other solution.